How's lunch? Wow. Now, I'm used to being loud, but that was very loud. Did you have a good lunch? Now, whenever I get a slot that is right after lunch, I tend to always tell people about my background. So I'm half Spanish, half Moroccan. And if I don't get a siesta, you don't get a siesta, okay? Now, I'm here to talk to you today about observability and basically how to effectively spy on your systems, if you will. Now, my name is Laila Bougria. I'm a software engineer, solution architect. I work for a company called Particular Software, where we build end-service bus. And you can find me online. You can find me here. Feel free to come and chat to me. Now, I'm assuming everyone knows what observability is, but, I still want to take some time to ensure that we align on the definition of that, right? So, for a system to be observable, we basically want to be able to understand how it's behaving, and that means both the expected state and the unexpected state that the system may arrive to, which kind of means that you need to be able to know what you don't know. Now, also, we want to be able to do that based on data that is stored outside of the system. So no going into your SQL Server database and querying data. That doesn't mean that your system is observable, because you're going into the system to get that insight. We want to be able to do that based on information that is stored outside of the system. And we also want to use specialized tools to actually analyze and query that information. And our main goal is that we can then extract actionable insights from that information to then go back to our application, improve it, make some changes, and see what can be improved. Maybe there's a bug to fix, or maybe there's some performance that we want to improve upon. Okay? Cool. Now, the question is, why would you want this in your system? And there are actually multiple reasons why you would want to make your system more observable. The first one is actually the reason that I got so interested in observability. Because like I said, I work for a company called Particular Software. We build a service bus, which is a framework that makes it easier for you to build message-driven, event-driven type of systems. But before I joined the company, I spent years building these systems out there in the field. And although I loved these types of architectures, one of the things that I really hated about it is that it's incredibly hard to troubleshoot failures, because usually something fails and you see something that happens, an exception somewhere. But in order to understand where that came from, you usually have to go find the root cause 5, 6, 7 services up. So that made it really complex, and that's one of the reasons that I got into observability. But it could also be because, you want to get a better sense of how your system is performing, whether it's healthy, whether everything is running. So basically, focus a little bit more on monitoring. Because again, we're in this microservice distributed system type of space, or, distributed balls of mud, whatever you're building, it's all good. But the thing is that when someone says, is the system up? That becomes a more tricky question to answer, because that means that all of the services should be up. Or maybe not necessarily. Maybe we want to know whether we can fulfill orders, and maybe there's just this reporting thing that is down. So that becomes a more difficult question to answer as well. We also may want to get better insights into the performance of our system. Because we've split everything up and components are interacting, usually we're not that interested in the performance of an individual component. We have perfect tools that can help us create that insights, like a bunch of the JetBrains tools, right? But now, in this distributed context, we actually want to be able to say, okay, this business process, how long does that take? How much latency was there? How long does it take overall for it to complete? Another reason could also be to catch side effects. Now, I'm not only talking about failures, but also the stuff that tends to linger in your system, right? Who's ever been in a situation where they finally find the bug and you're looking at all of your data and it's like, ooh, this has been here for 2 years, right? Those are the things I'm talking about. So observability can help us catch those a little bit up front as well, hopefully. Next, it could also be to get additional insight into your user segment behavior, right? Our user base can be really large, and we can have groups of those users that are behaving very differently, using the system in different ways. So we might also want to get additional insight into how they are using the system, what types of failures that they are running into, and what types of issues that we see for them as well. It could also be a way to better manage how we release features, because if you have a really large application and you're introducing a new feature, you just don't want to go all in and release it to your entire customer base. What we usually want to do is release it to a part of our user base and then take a look at, how's this running? Is everything going well? How do our users like it? Are there any issues occurring and things like that before we then go big bang? And then finally, chaos engineering, which is a very good technique to unleash chaos on your system. But the idea is basically that we're just going to start pressuring it to see where it starts failing first, and then based on that information, go and actually improve how our system is behaving, right? But without any idea of how your system is behaving from the outside, how are you going to go and fix that chaos that you're now perceiving? Now, I find that we're actually in a really interesting period when it comes to observability in this industry, because over the last few years, the industry has both been implementing and adopting the OpenTelemetry project. Now, OpenTelemetry is an open source observability project framework, and it's a project led by the Cloud Native Computing Foundation. And it's actually their second highest velocity project after Kubernetes, so it's pretty crazy. And it basically provides a set of APIs and SDKs and frameworks that enable us to basically standardize how we instrument, how we generate, and how we collect all of that information, all that telemetry from our applications. It is also available cross-runtime and cross-platform. 11 languages, is it? 12, okay, so 12 languages, there you go. So even if you find yourself in a multi-tech stack type of situation, then you can still use the same APIs and still get that same understanding. Now, there are 3 so-called observability signals. Maybe 4, but we'll talk about that later. Traces, logs, and metrics. Now, I'm going to assume that you already know what these are, since this is not an intro type of session. But what I'm trying to do with this session is give you some insight about the goals of the OpenTelemetry project and what they're giving us for these signals. What's added for us? Why is it interesting? And let's start with logs. Like, this is the oldest type of observability we know, right? Who's ever used logs in a system? Okay, yeah, that's everyone. So we basically went through a whole trajectory when it comes to this. Like, first we would just log to the event log and file system, and we would use like frameworks like Serilog and nlog and whatever it is. And then we were like, it's kind of messy that people put whatever text in there. So we also went from random text to more structured type of logging. We also sort of transitioned from keeping all this stuff on file system to more centralized type of logging. So we've seen the pains and we've made improvements, but there are still many issues today. Now, first of all, there's very weak integration with other observability signals. So if you're using logging in your system, but you also have metrics, you're also starting to use distributed tracing, connecting those things together is not something that could be done out of the box. That's something that OpenTelemetry aims to fix. This was usually so hard because we're using different types of collection agents, but also because there's a mismatch in the way that we label logs and the other signals as well. Now, there's also no standardized way to include the origin or source information. So what also tended to happen is that we're looking at all of our logs, which are beautifully centralized in some kind of tool that we're using, and then looking at those statements and where's this coming from? Like, we're just interchanging problems, right? Because before we kept it on the file system and we spent hours trying to figure out which server to log into to get to the right log file. And then we standardized everything and it's in one place, but now we don't understand where the log statements came from. So we keep playing that game. And then finally, it also really lacks a standard propagation mechanism. If you want to pass something along to then further enrich a log statement down the line, there was no standard way to do this. Now, what OpenTelemetry does is it basically introduced a unified log data model, which is nothing more than just an agreement, a shared contract of what a log statement should actually include, right? Now, it also includes support for distributed context propagation so that we can pass along information to then improve other log statements down the road or even other signals. We'll see more about that later. And it also does standardized log correlation. That's also based on multiple things that are included in that log data model. There are three things on which we do that log correlation, and that's time of execution, and the execution context, and then finally, where did this information come from? Which before was a very, very frustrating manual exercise. Now, when it comes to metrics, metrics also already existed long before the OpenTelemetry project came to be. So one of the focus points of the OpenTelemetry project is actually to make this work with existing metric protocols and standards, like for example, Prometheus or StatsD. Now, another thing that they considered, for those of you who don't know that, OpenTelemetry is basically based on two other standards, OpenCensus and OpenTracing, where OpenTracing is focused on distributed tracing alone, but OpenCensus had support for both distributed tracing and metrics. So there were already people using metrics with that OpenCensus standard. So there was also a migration path for those OpenCensus users so that we can really transfer everyone to this one standard, and it doesn't become like just the next standard that we come up with, and then the next one, and the next one. And then finally, the most interesting part for me is that they want to have this ability to correlate metrics to other signals, so that when you can see that a metric is off, you can actually connect that to, okay, which traces and logs are connected to something that is feeding into this metric causing this spike. And then finally, we have traces. Again, like I said, we had OpenCensus and OpenTracing. So here they wanted a clear migration path for any users of any of those previous standards. And the goal was also to be vendor agnostic. I mean, this is actually true for all of the signals, right? But basically, the goal was to have a standard format in which that data is being stored, in which that data is being collected, and also to make sure that you have the power over your data and that you're not faced with the situation where you're using a vendor and you want to get your data and they're like, yeah, that's proprietary. So basically to give you that flexibility to use whichever tool you want whenever you want. And it also means that you only need, or we as developers only need to learn a single set of APIs or conventions, which makes it a lot easier, especially when we want to switch. Because before it was like, okay, I know how to use application insights, but this other tool, whole other API. So when we have different signals, usually one of the questions that comes up is, okay, which one do I use and when? And as with any question in this industry, the answer is, it depends. Awesome. So one of the things I like to do is let's look at the strengths and weaknesses of each, and then based on that, make decisions, right? So for metrics, usually we want to get some insight into the health of our system. Is it, or maybe even like, is it performant, right? And usually we'll show that information on beautiful dashboards, which then nobody looks at, and that's why we need alerts, right? So that actually we get an email that tells us, something is going wrong, and that's when we will go look at the dashboards. Now, the thing with metrics is that it's basically an aggregated value. We're capturing very little context, but aggregating that information so that it can show us a trend of how things are sort of progressing over time. But that also means that we're losing a lot of context. That's just something that we do in order to be able to get that idea of a trend. When it comes to logs, they're awesome because they're human readable. Well, if we put enough time to make it actually human readable. But it allows you to add a high amount of detail, as much as you want, really. And one of the downsides is that it becomes really difficult to start connecting those logs across multiple services. It also covers a really small scope, and I find them today the best sort of use case for them is to use them in startup and shutdown scenarios. And when it comes to application-specific insights into what your system is doing, I would prefer traces because they give you the deepest amounts of insights that you would be able to get from what is happening in the system. Why? Because basically, it can give you that idea of performance over a whole trace, right? And that trace could represent a business transaction, really. It could go over multiple services, but you still get that full picture. Also, it gives you insight into the flow of events, what is happening after what, in which order, and what's leading to what. Apart from that, you can also sort of see how that data is changing as you go through those multiple spans or units of work, if you will. You could see in the first service, there's a variable discount that's set to 0, and then we have some discount service that actually calculates the discount because, I don't know, you're a silver customer or something like that, and then we see that value being filled in if you're capturing that down the line. It will give you the sort of most insight about the internal state of your system, and I really find that this has the richest data model because you can also add attributes that give it, that's basically like a key value dictionary that gives you an idea of, all of the things that make sense within that context that could give you insight in what's going on, but you could also capture events to signal that something is happening that is of importance. I basically like to think of metrics are telling you that something is going on, but if you want to figure out what and where and how, then logs and traces are usually what you're really looking at. Now, one of the questions that I tend to get a lot is that people, we've been building distributed systems for a while. We haven't necessarily always been paying attention to actually making them observable. So sometimes I get this question of like, I have this large distributed system. I want to make it observable. Where should I start? Because it's not that I can go back and start asking for weeks and weeks and weeks to now make this observable. And one of the things that I think is a good idea is to basically start at the edges of individual components. Because again, thinking that we are in this distributed systems landscapes, right? And we have multiple components that are interacting together. Usually, our blind spots are where that inter-service communication is happening. How services are communicating together, what data is coming back, what decisions are being made based on that information. And that's usually where we're blind. Now, the thing is that it's also the easiest place to add instrumentation, and from there on, you can basically start working your way in as you see fit and as you see necessary. And I'm saying that that's the easiest way to add instrumentation because the community has us really covered here with instrumentation libraries. Now, you will see a bunch of frameworks that are appearing on your screen, and if you look at them with the lens of that inter-service communication, we can already start closing a lot of gaps, right? HTTP client, ASP.NET Core, gRPC, but also the Azure SDK and the AWS SDK if maybe you're sending a message or you're publishing an event or storing something on Blob, whatever it is, right? So if you think about it that way, we're already closing a lot of those blind spots. And all of these libraries either have built-in instrumentation or offer a dedicated instrumentation library that you can then pull in and enable. So you might be thinking, okay, awesome. Then let's just turn on every instrumentation library on the planet, and that's it. Our system is now observable. We are done, right? But, sorry. That's when you start to look at all of that information, and you're like, okay, I can see a lot of traces spans, I can see a lot of logs, I see a lot of metrics, but wait a second, I'm still not understanding what is going on because sometimes they're just too noisy. And in some cases, they're not noisy enough. They're not giving you enough insight into what is going on. So these instrumentation libraries are a very great start. They're basically giving us that first step, but then we still need to be able to go back and take a look at how do we then need to add information to that to then, make it actually information that is actionable for us, right? And I feel that that's why we need an observability strategy. Now, we're all engineers. Are we all engineers? I don't want to assume. Okay, most of us are. So, and the thing is that when we're looking at frameworks like these, we're like, okay, how do we start using this? And how do we enable all of this? But if we want to be really effective and really successful at making our system observable across all of the components that we have, we need to take a couple of steps back and basically create alignment within your organization, especially if you have multiple teams that are working on a single system. One of the things that you should ask yourself is, what goal are we trying to achieve with all of this telemetry that we are collecting, right? And that has to be a clear goal, not like, oh, I watched this cool session at NDC and it seems like a good idea. No, I mean, there's always a need that we're trying to fulfill, right? And like I talked about in the beginning, there are many reasons and many benefits to making your system observable, but I really believe it's important that you're doing it for the right reasons. A next question to ask yourself is, who is going to use this telemetry and to what end? And the reason that I find this question so important is because I made the mistake years and years ago to be on a team where we had this epic to create dashboards and beautiful metrics, and we spent weeks working on that thing. Like, it was very, very pretty and very sophisticated based on application insights. Guess who looked at it? Nobody ever, right? So that was a completely wasted effort, complete waste of our time and of all the resources that we use. And that's why I think we should have a lot of clarity. Who's going to be looking at that data, and what are they expecting to get from that information? Also ask yourself, which signals do we already use today? Now, odds are that you're logging, as I saw all the hands go up. And how is that information currently being used? Maybe you're already using metrics. And the next question then is, can we introduce new signals? Maybe you're not doing distributed tracing yet. Who's doing that actually, just out of curiosity? Okay, a couple of hands. But maybe you're like, this is really cool and I want to start to use it. But you need to create that alignment across your organization, because even if you have the decision power to say, within our team, we're doing distributed tracing, okay, but then you still have this very narrow view of what's happening in your system. You really want to create that alignment across all of the teams. And then finally, what I also always recommend is to have a couple of questions ready that can give you insight into, what should this telemetry actually be able to answer for me? And I'm going to give you a couple of examples. Now, the first one that I like to bring up is, okay, who's ever gotten a ticket to fix an issue and then try to reproduce it, and it's like, yeah, well, it works on my machine. Yeah, everyone, right? And the thing is that this user that actually opened that ticket, I mean, they weren't psychotic. They actually saw some friction. But the thing is that users aren't usually in that mindset of, let me think about every step I'm taking so that if an exception maybe occurs, I'm able to tell them exactly what I did. They're not in that frame of mind, right? But what if you would be able to basically connect a specific user action to your telemetry and be able to say, oh, that was John, Friday, 3 p.m. And then you would get that insight and actually see what happened there. Or how easily can you group similar behavior together, things that stand out in performance or in latency, or maybe in specific attributes like, oh, these are premium customers. Can you identify the most load-generating operations that are happening in your system? Like, are they happening at a specific time of the day, or are they very specific to a specific region or something like that? Might give you some insight in where you need to scale or rearrange. Can you identify which users are stressing the system? What are they doing? In what order? And why? And finally, how easily can you find suspicious events throughout the system? Now, these are just a couple of my examples. The idea is that you come up with your own questions so that whenever someone is creating a new feature or changing some kind of logic, they can actually look at these questions and then ask themselves, what telemetry do I need to create in order to be able to answer those questions? And that can then feed into what I like to call observability guidelines, right? Now, these guidelines should be then again available to every team across the organization so that you get the same quality of instrumentation independent of the team who worked on it. So one of the things to include there is which signals are available to us, right? Like I said, you don't want one team in the wild to start introducing someone that then nobody's ever going to look at. We need to have that communication. Also, if this is sort of a new topic in your organization, have some guidelines on which scenarios best fit each signal in your specific context. What do you expect to see? And also the questions that the telemetry should answer that we just looked at. And then finally, also some of the best practices that they should consider when they're creating application-specific telemetry. Now, when it comes to best practices, there's like whole books written on the subject. And I have a bunch of those in the resources at the end if you want to learn more. But what I did is made my own selection of the ones that I feel are important and I really want to share with you here today. The first one is around handling error scenarios, right? Because at least I feel that, the more experience I gain and the older I get, I'm more convinced that just creating a feature is the easy part of the job. And I'm thinking of everything that could go wrong and how we're supposed to handle that is where things get tricky, right? So what we want to do is whenever something occurs, whenever, an error occurs, we want to capture any possible failure scenarios so that we can get insight into what happened there. Now, at that point, we also want to make sure that we signal those failures to the observability backend by setting the right statuses so that we can easily search for them later and find those. We want to include error information, right, from your error message, stack trace, inner exceptions, all of that. And then another thing that you could do is consider adding additional information when a failure occurs, because maybe sometimes you don't want to add all of that information for all the successful scenarios, but in case something happens, you want to add some additional information so that's captured and you get more context specifically because this is something that you're going to be looking into. Another really important thing is that any instrumentation should never cause business failures. Because at the end of the day, no matter how important, right, the telemetry is and observability is, it is not a mission-critical component of our application, right? At the end of the day, our business needs to be running. So if we then go and add instrumentation code and we deploy that and people can't order stuff anymore, then that's not a great scenario to be in. So it's really important that you think thoroughly about the code that you're adding, that you also test that as part of your testing strategy as well. Another one I want to talk about is context propagation, because in order to make all of the telemetry that we have even more insightful, it needs to be connected, right? And that's one of the goals of the baggage API. Now, this is also actually listed as an observability signal, but I think it's kind of a special one because this doesn't necessarily end up like directly in your observability backend. Now, this is available for different signals, and it basically allows you to capture information that you're then going to pass on that you can then use to further improve other signals that you're emitting at a later point. But you have to be really, really, really careful with this and actually consider in most cases not to use it because it doesn't come without risks. First of all, it does have an impact on latency because you're adding stuff on that is being propagated across multiple services. Now, if you're just adding some small information, it's probably not that problem, but you have to be aware that you can't add a collection of 25,000 products on that. And then the most important one is that everything that you add on baggage is going to be available on every hop after that, especially if you have auto instrumentation enabled. And that is really important to be aware of, because it also means that if you are integrating with third parties, you don't know what's in baggage because you don't know what that third party put into baggage. So you might be exposed to information that they put on there. But the reverse is also true. Whatever you put on there could be seen by third parties that you're integrating with because that data is being passed along in another HTTP header, right? And that makes it especially tricky when it comes to sensitive information, right? Now, I would say that this is true for any kind of telemetry that you collect, but you don't want any personally identifiable information in there. Nothing that can be traced back to an individual. Because then you get a GDPR request and you're like, well, I don't know, right? So use an ID or something, but that can't be necessarily traced to an individual. Also, financial healthcare data, something that you want to stay away from. Passwords, connection information, any type of infrastructure information, right? How many times have we not checked in a connection string? Like, these things happen. Even though we all know this, these are like, honest mistakes. We're not always paying as much attention as we would want to. So how do you keep this data out? Well, one of the first tools that I always refer to are code reviews. Now, I have a sort of different approach. I find, especially when I'm talking to a lot of peers, I see that they don't necessarily look at PR reviews the same way as I do. And I basically look at it with multiple hats. So when a feature is built and then someone pings me for a review, I will go to that PR and first put on my feature hat. Okay, what were the requirements? Would this work? Did we forget any, edge cases? Or maybe are there any design decisions that are important that we need to maybe talk about? That's my first hat. And then I'll be like, okay, let me look at this from the testing perspective, right? Is this sufficiently tested? Did we forget any test cases that are important, and so on? And then you can put on your third observability hat and see, okay, did we add enough telemetry or did we add too much telemetry to get insight into what's going on? What are we adding on here? Is there any sensitive information in there? And things like that. But there are also other ways, of course, to handle this. You can also, encrypt certain information, tokenize certain information, and also, for example, mask and redact something out. And of course, this is not something that you want to trust your teams with, right? You'd rather do this in a centralized way. You don't want to rely on individuals remembering to actually do that. And then that's something that OpenTelemetry processors can basically help us with, right? Let's say that you choose to encrypt certain information. Then you could have a processor through which all the telemetry goes, and that basically is then maybe encrypted and then pass to the next processor if there is one in line. So we were basically going to manipulate that data before it's exported to the observability backend. Sort of reminds me of the pipes and filters pattern. We can basically further enrich or filter some of that information out. And there are different types of processors that you can use per telemetry signal. Again, be a little bit careful here because that's going to run on all of the telemetry that you collect. So don't do some crazy stuff in there. Be aware that that can also slow things down. And at the end of the day, your goal with that telemetry information is to get it into the observability backend as quickly as possible so that it can actually feed our insights and our metrics and all of that. And that brings me to the last best practice that I want to talk about today, and that's telemetry correlation. Because we already talked about the multiple signals, and there are different reasons why we'd want to use individual ones, right? Each individual signal provides its own type of value. But when it really becomes powerful is when we are able to connect all of that information together. Because that would further strengthen our observability. If we see that there's a metric off, and we would be able to connect that to the traces, and from the traces be able to look at the logs without having to do any manual exercise, then based on that information that is just linked already there for us, then we're losing a lot less time. So that reduces the mean time to resolve, which is a metric that gives us insight into how quickly we're able to resolve an incident when it occurs. So what we want to do is connect our logs and traces. So basically what's going to happen is that in our log format, we're going to have the trace ID and the span ID included so that that information is connected. If you're looking at traces, you know how to find logs, and the other way around as well. And we can also consider capturing trace ID in what's called metric exemplars. But here we have to be a little bit careful to not introduce what is called cardinality explosion. Now, what is that exactly? Well, think of a metric as something that you can add labels to. right? So let's say that we want to capture a metric for the amount of failures that is possibly happening in our system. And we want to add a label to that to get insight into which HTTP status code was that. But we also want to capture the environment in which that may be occurring. Now, when you think about the cardinality, you have to think about every possible single label value each of those labels could have, and that is your cardinality. Now, depending on which observability backend you use, sometimes a series is created for each individual unique combination. And this is fine. But imagine if you add something like request ID or span ID. Then you could just have this explosion of possible options, making your bill very, very expensive, and also your ability to query not so great. But there are tools out there that actually support high cardinality, like Honeycomb. You're welcome, Martin. So it's important to just have that insight into how's that observability backend working, and to have that in the back of your mind. These are some additional best practices for you, and then time for me to take a sip of water. Okay. So with this in mind, we've now taken the time to actually make all that telemetry that we are collecting actionable, right? We want to be able to actually use this to improve our system. So at this point, we might want to say, okay, we have this high quality instrumentation. Now it's really safe to collect all of the things. And I would say that that's true, but then at some point there's this manager looking at a piece of paper in their office like, oh my gosh, what is this, right? Because if you're in a very, very high throughput scenario, even if it's super actionable, that might just be way too much information to store, and it can become expensive, right? And this is where you want to be thinking about, okay, maybe we should start sampling some of that data. Now, you can do that with logs and traces, but for the rest of this session, I'm going to be focusing on tracing. Now, to solve this problem, we basically need to start to ask ourselves, what data do I actually use? Because if you think about all of the traces that are emitted by a single system, you have a very large set of successful traces. At least that's what I hope for you. Then you have this small set of errors that might be occurring. You have some that stand out because they're high in latency, and then some that are interesting because they carry a few attributes that make them interesting within your specific business context. But do you really want to keep all of them? Or would it actually be sufficient to take a random sample of those successful traces and then keep all of the other interesting ones? Right? We also always want that random sample of the successful ones to have a baseline as well. So what would be sufficient in order for your system to be observable? And again, that's where it comes back to your observability strategy. What is it that you want to achieve? So if you're like, I want to be able to debug any request that happens in the system, well, then you can't sample. Then you just need to keep everything and pay the bill. Or if you would say, well, I want to be able to debug system-wide problems, then you would get away with a lot less traces. If you would like to say, I want to understand the baseline behavior of your system, you can even further reduce that. But it could even be that you just walked into a system landscape where there's like zero documentation, and you're like, I don't know how the system works. And I'm basically going from department to department, and they're telling me different stories, and it's going to take me 7 months to just figure out how this works. It's also something you could do with observability, is just get an idea of how is the system interacting. But then just 1% would maybe be enough to get an idea of how things are working. So again, it's really important to understand what your goal is. And then once that's clear, we can start looking at the different types of sampling strategies that are available to us. Now, there are two ways to sample traces. There's head sampling and tail sampling available. With head sampling, what's basically going to happen is that we're going to make the sampling decision at the beginning of the trace. So basically, at the beginning, we're going to make a decision of, this is interesting and we want to keep it or not. Basically, the root span is making that decision, and that's then being forwarded to the rest of the system. Now, the default way in which this worked is based on the parent-based sampler, which is a composite one, and is most commonly used with a trace ID ratio-based sampler. Why did I make that so difficult? Now, that one is really good if you want to get unbiased sampling. It's like purely random, but it's also going to be repeatable. So even if at any point you're basically going to execute that sampling decision again, it's basically going to be deterministic. And then it's important to remember that your spans are still created, they're just not being recorded. But Martin has a very good blog post on why you shouldn't necessarily care about that. I still want to mention it because I don't know what types of systems you're building. If you care about performance to the point of, I don't know, ticks, then maybe this is something you want to be aware of. When it comes to tail sampling, it's completely different because what we're going to do is we're going to collect all of the spans that pertain to that specific trace and at the end decide whether we want to keep it or not. That basically, we are allowed to do that based on the overall trace duration, right? This is a slow one. Based on the status, this failed, so we want to definitely keep it, or based on the span attributes values. And again, you'll be like, okay, but how do I choose between them? You're giving me all of these options. So it's game of trade-offs again, right? Head sampling is very easy to configure, and it's easy to understand because you know at the beginning what's going to happen, right? Non-sample traces also are not going to affect latency because you're not going to collect anything because you already know that you're not going to need it. So nothing is going to be forwarded, nothing's going to be collected. That also means that you have reduced data transmission. But that sampling decision also needs to be propagated, and it needs to be respected by all of the upcoming services. But the main downside is that it's impossible to anticipate whether this trace is going to be interesting, right? You don't know whether this is going to fail up front, and you don't know whether this is going to be slow up front. Maybe there's even specific attributes that you don't know at this point in time, but you only know at the end. Now, when it comes to tail sampling, that allows you to fix that problem because you can basically put yourself in a position where you never lose an important trace again because you have full control on what is important and what is not. There is going to be a latency and performance impact because you're collecting all of those spans until the trace is completed before you make that decision on whether to keep it or not. It's also tricky to sort of figure out, like, when is a trace finished? Because we can't always know that, right? Especially if we have things like automated retries, or we're being rate limited and we're sort of respecting that limit that's being imposed on us, then things might just take longer than we expect. So usually this is fixed with just a cutoff time, 4 or 5 seconds, whatever it is. But that means that sometimes we could just be breaking it off a bit early. You're still exposed to potentially unpredictable costs when you're doing tail sampling, because if we're saying we're going to collect all errors, and then there's an Azure outage, we still have a huge spike into the amount of traces that we're collecting. And there's also pressure on the service that is making the sampling decisions, although there are ways to mitigate that as well. And it's sort of trickier to get right. I mean, with flexibility, it's always a bit complicated to handle that. Now, one of the questions that then tends to come up is, okay, where do I implement my sampling strategies? Because if you look at a lot of those simple getting started samples out there, usually they make use of a sort of direct export to the backend, right? We're collecting information and we've added exporter to application insights or honeycomb or whatever it is. So that information is being sent by the service to the observability backend. Now, that exposes us to a couple of challenges because there's an increased load on that service. It also means that we're exposed to communication issues with that backend service. And there's also no central configuration point. So if you want to change how certain things behave, you have to change it across all of your services and redeploy them. So that's a bit tricky. Finally, also no central data management pipelines. So those are real challenges, and it could expose us to business failures. But luckily, there are other options available to us. To visualize a little bit how this works, we still have each individual service that is receiving, processing, and exporting telemetry information directly to the observability backend. When it comes to other options, there's the OpenTelemetry Collector to help us out. Now, this is basically a vendor-agnostic implementation, yet again, that's sort of true across the board. That allows you to sort of receive, process, and export telemetry data. And the main goal is to sort of be a mediation layer between all of your services in that observability backend. And it makes it a lot easier to adjust all of those things because it's centralizing that configuration management. It also offloads those risks of failures and handles those error scenarios. So if it can't communicate with the observability backend, it can just retry and hang on to that data just a little bit longer, for example. And it also allows you to start scaling per signal. If you're saying, like, we're doing mostly distributed tracing now, just a little bit of logging, then you can also sort of tweak those things independently. Now, one of the options to deploy the OpenTelemetry Collector is to use a sidecar option. Now, in this case, what we're basically going to do is release a sidecar per service, right? And that offloads all of those responsibilities that we talked about to that sidecar service. And the individual business service can just focus on what it's supposed to do, the business stuff, right? It can handle things like batching and retries and encryption and compression and all of that. It can also then, usually you want that running on the same node as your service. Why? Because that way you don't have any latency, right? But it can still sort of handle those concerns individually outside the process of your business service. And it can also handle those communication issues that might occur with the backend. To visualize how that looks like, we now have each individual service with a sidecar that is the OpenTelemetry Collector, and the individual service sends that information to its sidecar, which then will propagate it further to the observability backend after it's done its processing and all of that information. Another option is to use the gateway cluster option. Now, in this case, we basically have a standalone service that is running the OpenTelemetry Collector, if you will. Now, this is easy to scale with a load balancer and actually required if you're doing tail-based sampling. Why is that so important? Because every span that pertains to an individual trace needs to be handled always by the same OpenTelemetry Collector instance so that it can make a decision at the end of whether to keep it or not. Now that looks like this. So now we have our individual services that are just collecting that information, sending it through to the centralized OpenTelemetry Collector, which is then doing that receiving, processing, and exporting to the observability backend. And you could even go a little crazy and sort of have a hybrid implementation of this, where you have a single service that always has a sidecar, or maybe not for all your services, but where it makes sense, and then the OpenTelemetry Collector in the middle. Where would that make sense? If you have some very individual concerns to handle for a specific service, maybe you want some specific service processing there that doesn't make sense for all the telemetry, but it would be useful in the specific context of a single service. And then you can go totally crazy, put a load balancer in the middle and actually scale out the collector. So again, many options, and you're asking okay, which one, right? Now, the thing is that in order to answer that question, you need to get insight into how much telemetry you're collecting, right? We need to get a sense of the scale that you expect. Now, as engineers, we also have a tendency to overinterpret the scale that we're going to receive, right? We're looking to cater for 100,000 users. How many do you have? 10, right? So it's important to start small, because the reality is that you're probably not Google or Amazon, Netflix, Spotify, whatever it is. So it's important to start really simple and to look at, what do I actually need? You don't want to introduce all of that infrastructure complexity from the get-go. So what I would usually start with is with a centralized OpenTelemetry Collector and build your way up from there. to whatever it is that you actually really need. So, in short, keep it simple, start small, and build your way up as you actually see a need to build yourself up. And that is bringing me to the end of this session. Now, if we want to be really successful at making our systems observable, we can't treat it as an afterthought. And that's why already you can probably Google observability-driven development. It has to be part of your train of thought as you're developing new features, as you're editing parts of your code base, and as you're building the system. It's always going to have to be present, those observability guidelines, right? How do I make my system observable? What are the questions that we need to answer? So it's important that you build an observability strategy and that you have that shared across your organization so that it doesn't depend on individual teams who are just really thorough or who may maybe have all of that knowledge. We want the same quality of telemetry across all of those teams that we have, because otherwise you're just looking at your observability backend, seeing really useful information, and then there's a blind spot again. Also, you need to play that game of trade-offs, right? What is it that you need the most? What is it that what are you willing to, the effort that you're willing to put into it, what are you willing to pay? And that's where you can start looking into different types of sampling strategies and looking into different types of deployment models. Now, if you are looking to learn more about observability, they have this beautiful hashtag that you can look for any content out there. But as always, I also have additional resources available for you, a bunch of articles, a bunch of books that are very good reads. And yeah, you can always feel free to reach out if you have any questions as well. Thank you for listening.